Hey everyone, in this video we're going to look at one method to solve systems of equations. We're going to look at the substitution method. So what I'd like to do is take a look at an example, we'll go through how to solve that example, and while we're doing that I'll explain each of the steps as we go. So here's my system. I have two equations, they both have the variables x and y, and the way it stands right now I can't outright solve for either of these variables. And that's where our methods for solving systems come into play. So what I want to do is I want to take one of these equations, I want to rearrange it so that one of the variables is all by itself, and then I can take that expression, substitute it into the other equation, and that's going to give me an equation that only has one variable in it, and then I can actually solve. So the first step is we need to choose one of these equations, and we're going to choose either x or y, and we're going to isolate it. Now there's no wrong answer here. Doesn't matter which one you choose, doesn't matter which variable, but sometimes there are ones that are easier. So for example, I think I'm going to choose this first equation. And the reason I'm going to choose that one is because my x already has a coefficient of 1. That means it's going to be very easy to isolate it. If I want to isolate x, all I have to do is add 4y to both sides. And what I end up with is this expression for x. So adding 4y, we get 4y minus 7, and the x is all by itself. So what this is telling me is x is the same as this expression. It's the same as 4y minus 7. And if that's true, that means I can take this expression, I can substitute it back into x into my second equation, and that's going to give me an equation that only has y's. So let's take a look at that. So the second equation, 2x plus 3y equals 19. And now instead of x, we're going to substitute in this expression that we found, 4y minus 7. And then we still have the plus 3y is equal to 19. So with that substitution, we now have an equation where the only variable is y's. And since it's the only variable, we can actually solve for it. So we'll just go through that process quick. We'll start by distributing the 2. 2 times 4y is 8y. 2 times negative 7, we have negative 14. And then plus 3y is equal to 19. Combining like terms, 8y and 3y is 11y. And isolating the variable term, we'll add 14 to both sides. And we get 11y is equal to 33. And dividing by 11, we're able to solve for our y value, and we know it's 3. So that's the first big step, right? We went from having two equations with two variables, we combined them together in a strategic way so that we had one equation with only one variable, and then we were actually able to solve for it. And now that I know this first variable, now that I know what y is, I can take this value, go back to what I was working with before, and I can find x. So we know x is equal to this expression, so x is going to be equal to 4, and instead of y, we'll substitute in 3 minus 7. So that gives me 12 minus 7, and x is equal to 5. And then for my final answer here, what I'm going to write this as is an ordered pair. Since both of these equations are linear, meaning they represent a line, the solution to the system represents their point of intersection. So we want to express our answer as the ordered pair 5, 3.